When you want to deploy your application, you have probably heard about Docker and containerization. Now, when you want to create your own containers, there are some key concepts that you need to know about in order to write optimized Docker files. And that's something I want to take a look at in this video. In front of me here, I have a really basic Hono application. It has some endpoints for health, where we can check the health of the service. You can get some recipes, and that's basically all there is. So if you haven't worked with Docker before, I'm not going to go over the basics. I'm going to go a bit more into details about how Docker works and how the images are built, so that we can use this knowledge to optimize our images. In front of me, I have a Dockerfile that is not optimal at all. What it's doing is that it's installing a PNPM. We're copying all the files from our current directory into the container. Then we're installing the dependencies, and then we're serving the dev server. Now, this is something that you typically want to avoid, especially when you want to wrap or build your application into a container that you want to serve in a production environment. If you want to Dockerize your container for being able to develop in container, this might be something you can do. But for production, you don't want to do this because there are a lot of additional tools you need in order to have your dev server. For example, you have hot reloading so that when you do changes in your code, the application automatically updates. And these are tools that you don't really need in a production setting. So the first step to improve this file is, instead of serving the development version of our application, we're actually going to build it and serve the build version instead. So here I have added the next step, which is to build our application, which is this single line right here that we added. And then we're going to serve our build version instead of doing pnpm dev. This will take our source code from our directory and only take the necessary files that it need, go through the build process and output the code that our application actually needs to run. And then we can serve this instead of serving the developer server. It has a lot of additional add-ons. Now, there are still quite a lot of problems with the Dockerfile. The first one is that we're copying everything from our directory into this container. Then we're doing pnpm install. Now, how Docker works is that there are two kind of terminologies that you need to know about, and these are stages and layers. Layers is basically each single line is one layer, and these are also something that you can refer to as instructions. And what this does is that it's like the recipe that Docker uses to build your image one instruction at a time or one layer at a time. And how Docker works is that each layer are cached by Docker automatically. So if there hasn't been any changes for the specific layer, it will check the cache and use the cache instead. Now, if there have been changes, then it can no longer use the cache and it will have to do all the work over again. And the problem with this is that when you build an application, your dependency doesn't change that often. You might introduce new dependencies and you might update the version, but that doesn't happen nearly as often as when you change your actual source code. So when we know about layers, we know about caching, and we know how that works, we can actually write our Docker file to take advantage of this. So instead of copying everything into the container and then installing everything, we can copy only the package.json and pnpm block, then we can install the dependencies. And then when that's done, we can copy the rest of our code into the container before doing the build. This way, when we change our source code, these layers will still be cached and go much faster to build. So if I now build my image, you can see that I've already done this before, so it will cache a lot of the stages. But if I now go into source and I go into my health control, for example, and I change this endpoint and I rebuild, you will see that from this copy step, it can no longer use the cache because there are files in this scope set that changed. However, copying package.json and installing the dependencies were cached. And this is one way you can optimize Docker so that running it will take less time. Now, the next thing we can do is actually optimize the size of the image. Because if I list all the images I have quite a lot, but we want to look at this tutorial one, and we can see that it is 395 megabytes. And that's not that big, but we can make it even smaller. And the way we do that is we introduce stages. Right now, we have only one stage, and that is called this base, and this does everything. Now, when you design your Dockerfile, you typically want to divide it into at least two stages, one called base or run or installer or something like that, builder maybe. And then you want to have a separate stage that just takes the output of the build stage and runs the code. Because when we build our application, we need some additional tooling to be able to take our source code and produce the build output, similar to how our dev server needs additional tooling. For example, one of those tools is PNPM. I'm installing PNPM here. This is used to install dependencies and to build, but we don't need PNPM to run our application. All we need is Node. So how we can fix this is that I still have this base page. I've just called it builder. I'm doing the same thing. I'm setting the work directory. I'm installing PNPM, copying everything in, installing dependencies, copying the rest of the code and building. But then we have this next stage. And these stages are just marked as this one. We have from, we have like a base image, which is going to be node 22 Alpine. And then I give it a name of runner. You can choose whatever you want, but these are typically called something that I have here, like builder and runner. And what we do is that we first just change the work directory to app, and then we copy whatever we want from the build stage to our runner stage, and we only want to copy the thing that we actually need. So our build stage produced this dist folder inside the app directory, and this is the build output of our application. So we copy that into this stage, and then we also copy node modules because we have dependencies that our application uses. And then we provide this command at the end that will tell Docker how to run our application. So if I now build the application and we check the size of it, we can see that now it is only 298 megabytes. So it got reduced by 100 megabytes. Now, this is not a lot in this case, but when you build more complex system, they will probably be bigger and you can actually reduce quite a lot doing this strategy. Now, the final thing I want to talk about is that currently when we run our application, we are running it as a root user of this container. And this is something that you typically don't want to do just because you don't want to run the application as a user which has all the privileges for the container. You want to create another user that only has privileges to run the application. And we can do this by, in the runner stage, we create a new group and we create a new user. Then we change the permissions of our app so that the user and the group can run it. And then we change to the new user that we created above. And this time, when the application runs, it's running at this user, which does not have as many privileges as the root would have. So this is just something you want to do to make your app a little bit more secure. And with that, we have a pretty complete Dockerfile that is quite optimized. Now, there might be some topics I haven't talked about in this video. If you know about any that I should have included, please leave a comment. If you have any feedback about the video or about the channel, also please leave a comment, drop a like if you like the video, and I will see you all in the next one.